Hello and welcome to Notes 2C Solving Inequalities. Today we're going to learn about how to solve linear inequalities, which is basically like solving linear equations, except when you are multiplying or dividing by a negative, the direction of the inequality is going to actually flip. So that's the key difference. And this is under the performance indicator. I can solve basic linear inequalities in one variable, as well as inequalities involving conjunctions and disjunctions. So let's take a look at an example. Right here, if this was a basic equation, if that was an equal sign instead of a less than sign, I would always begin off by adding 1 to both sides, which is what I'm going to do. So I get 2x is less than 10. Well, that just becomes x is less than 5. Now I'm going to graph this, and we always graph these on number lines, and y'all probably don't remember, but just in case, in Algebra 1, you learned that the symbols less than and greater than are always graphed with an open circle, whereas less than or equal to and greater than or equal to are always graphed with a closed circle. So just to keep in mind. So when I'm graphing x is less than 5, I'm going to put 5 on my number line. And because it's a less than, I put an open circle. And I want to shade in the area where that's true. Where numbers would that be true would be numbers less than 5. So I'm going to shade down my number line. Now let's take a look at another example. Again, we're going to solve it just like an equation. I'm going to subtract 2 both sides. So I have negative 3x is greater than 12. And this next step is where it starts to differ. I'm now going to divide both sides by a negative number. So when I do that, I get that x is less than negative 4. My symbol flipped. And we are again going to graph it. So I put negative 4 on my number line. It's a less than symbol, so I put an open circle. And I want to shade any number for which that is true. I shade below negative 4 on my number line. All right, guys, I want y'all to try this one on your own. Pause your video, go for it, and we'll check it in class. All right, so some inequalities simplify statements that are always true and some that are never true. We're going to look at 2 examples now. So for example, I am going to start off by solving this inequality by distributing the 3 inside the parentheses. So I get 3x plus 9 is greater than or equal to 6 plus 3x. I'm going to subtract 3x from both sides, leaving with 9 is greater than or equal to 6. When I look at this statement here is always true. When my statement is always true, it doesn't matter what the value of x is. That's going to be true. So my solution is all real numbers. Now let's look at this other one. Here, I am going to start off by simplifying both sides. I get negative x plus 4 is less than negative x plus 4. I'm going to add x to both sides to get that 4 is less than 4. Well, that's never true. 4 is never less than 4. So because that's never true, it doesn't matter what I plug in for x, I will never get a solution. So we'd say no solution. Or if we're going to write that symbolically, we write it like a 0 with a slash through it. All right. We can also set up word problems involving inequalities. This is one that y'all probably should know how to do because you might want to do this when calculating what you can and can't get on tests. Your test scores are 82, 76, and 78. What is the lowest score you can make on your next test in order to have an average of at least an 80? Well, that word right there, average, tells me how to start the problem. I'm going to let x, my variable, be your grade on a test. And I'm going to set up an average problem. I want the average. Well, average is the sum of all of your grades, and my last one is x, divided by the number of items. And I want this to be at least 80. So I want this sum to be at least greater than or equal to an 80, bare minimum. So I'm going to simplify this down. I get 236 plus x over 4 is greater than 80. Then I'm going to multiply both sides by 4 to clear the fraction. 236 plus x is greater than 320. And then subtract to get that x is greater than or equal to, oh gosh guys, I dropped that or equal to sign, 84. So you can score an 84 or higher to get at least an 80 for your test average. We also have compound inequalities. These are statements that are joined by the word and are considered a conjunction. And the conjunction is a set of numbers that is in common with both, or it's also called the intersection. So what does that really mean? When I'm graphing these inequalities and I see the word and, that means I want to take the set of numbers that's true for both of my sets. So let's look at that. Let's say I've got x is less than 3. So I'm going to graph that. I've got 3 right here on my number line. Less than means shade below. Then I have x is greater than 0. Greater than 0 means shade above 0. I want the conjunction. I want what's true for both of them. So when I look at both of these, if I look at between 0 and 3, the part that they share is this part here. So really, what I want is between 0 and 3. So my answer ends up being 0 is less than x is less than 3. Let's look at another one. Here I've got x is greater than or equal to negative 4. So greater than or equal to, we put a solid spot for greater than or equal to, and greater than we shade above. X is less than or equal to 2. Solid spot on 2. Less than or equal to means shade below. And again, I want to take what's in common. Well, what's in common, where they're both shaded at the same time, is this area here. So my answer is negative 4 is less than or equal to x is less than or equal to 2. Again, I'm paying close attention to my symbols. Let's take a look at part D now. Well, wait, I think I skipped C. Sorry, guys, we're going back. Part C, which is kind of cool as well. Part C, I've got x is less than negative 2, so I shade an open circle below negative 2. X is greater than 2, open circle above 2. I want to see what's in common. When I look at this, there's no single area here where they're both shaded. So here I have no solution. This guy is an empty set. There is no overlap, therefore there is no solution. Now let's look at D. So D, I have x is greater, or x is less than 4, open circle on 4, shade way below all the way down. Then I have x is less than 1, open circle on 1, shade below. I want the intersection when x is less than 4 and less than 1. Well, when I look at this, the area where they're both happening is this area here. It's all right here. So my answer ends up just being x is less than 1, because that's the only area where they're both shaded. Now, we've had statements joined by and, now we're going to look at statements joined by or. Statements joined by or are a disjunction, and which is a combination of the numbers in both sets, or say the more the merrier, which is really cute, also called the union. So here you're looking to combine your sets. So let's take a look at an example. If I've got x is less than 3, well, I'm going to graph that. Open circle on 3, graphing downward. X is greater than 0, open circle on 0, going upward. I want to take any section where there's any squiggles whatsoever. Well, looking at this, I've got squiggles in this section, and in this section, and in this section. So my answer is all real numbers. All of these are correct. Now let's take a look at B. Here I want to graph x is greater than 2, open circle on 2, graph up. Then I want to graph x is less than 2, open circle on 2, graph below. Well, when I'm looking at this, I've got squiggles everywhere except, if you look, 2. Every single number here could be an answer except the physical number 2 because of the type of symbols we were given. So my answer is all real numbers except x not equal to 2. And let's take a look at this one. Here I've got x is less than -3. I do an open circle on -3, shade down. X is greater than 2, open circle on 2, shade up. I want to take any area where there's squiggle marks. Well, I've got squiggle all along here to -3, and I've got squiggle all above 2. So my answer set is the combination of those two. It ends up being x is less than -3 or x is greater than 2. And finally, D, I've got x is less than 4, so I'm going to put an open circle on 4 and shade below. X is less than 1, open circle on 1, shade below. And again, I want to take wherever there's any squiggling. Well, here I could answer all of this, including 1, because even though 1's not included in this set here, it is, however, included in the first set, all the way up to 4. Boom. So my answer ends up being x is less than 4. So what I want you guys now is to try these compound inequalities, try these 10 problems, take a look at them, we'll go over them in class. And now let's take a look at example 3. So for this example, we're going to solve these inequalities just like if they were equations, but now we've got, rather than one equal sign, we've got 2 inequality symbols. Whatever I do to one thing, I have to do to all 3 pieces. So let's start here. If I've got -7 is less than or equal to 3x minus 1 is less than 11, I'm going to start off by adding 1 to everything. So I end up with -6 is less than or equal to 3x is less than or just plain old less than 12. Then, if I want to get the x by itself, I divide everything 3 by 3. So I get -2 is less than or equal to x is less than 4. And I'm going to graph that to show my answer. So I've got a closed circle at 2. That's a 2, by the way. I don't think y'all can see that. Should be a 2. And then an open circle at 4. And everything in between is shaded. Now for this next one, I want common denominator. To get rid of my fraction, multiply everything through by 12. I get 5 is less than -2x plus 9 is less than or equal to 11. Start solving this just like a normal equation. I'm going to subtract 9 from everything. So I get -4 is less than -2x is less than or equal to 2. Then I'm going to divide everything through by -2. Now every time we divide by a negative, remember that flips these symbols. So I end up getting 2 is greater than x, which is greater than or equal to -1. And so when I graph this, this is no longer in our least to greatest order. I have a closed dot on -1, an open circle on 2, and I want what's in between. And that's how we do that. All right, guys, make sure you did those 10 problems in the middle of the notes in the first try me, and we will see you all in class. Thank you.